Protein supplementation in burn patients. Severe burn injury over 30% or more of the body's surface results in pronounced metabolic response that has prolonged nutritional implications. Understanding the nature of this response and the consequent changes in nutritional requirements is important for the optimal treatment of such patients. The expenditure of resting energy after a burn injury can be as much as 100%. Increased heat loss from the burn wound and increased beta-adrenergic activity are probably both important factors that cause an increase in the resting energy expenditure. Burned skin loses its effectiveness as a barrier to water loss, leading to increased evaporative heat loss via the wound. In addition, radiation heat loss is increased from burn wounds. This is brought about by the increased blood supply to the burn wound, which is a normal response to any injury. Major trauma, burns, and sepsis have in common a rapid net catabolism of body protein, as well as a redistribution of the nitrogen pool within the body. Muscle protein breakdown is accelerated, whereas certain rapidly produced acute phase proteins are produced at an increased rate in the liver. Wound repair requires amino acids for protein synthesis, and increased immunological activity may also require accelerated protein synthesis. The body loses protein through wounds, and because of this, the body has increased calorie needs for healing. Provision of dietary protein and/or free-form amino acids is essential for minimizing net protein catabolism. Providing an increased intake of protein does not stop the breakdown of muscle protein breakdown for the production of energy, rather it provides the materials needed to synthesize lost tissue. Even a mild stress of simple bed rest increases the protein requirement to maintain a positive nitrogen balance. It is recommended that protein be provided to adults at a rate between 1.2 and 1.5 grams of protein per kilogram per day. Children normally require more protein than adults in order to support growth. Hence, it is suggested that pediatric patients with burn injuries be given as much as 3 grams of protein per kilogram per day. In children, approximately 25% of total energy should come from protein. In patients with major burn injuries, infection remains the major cause of death. Immune consequences of this injury have been identified and are specific deficits in neutrophil chemotaxis, phagocytosis, and intracellular bacterial killing. A reduction in immunoglobulin synthesis also has been encountered in these seriously ill patients. In patients with major burn injuries, infection remains the major cause of death. Immune consequences of this injury have been identified, such as deficits in neutrophils chemotaxis, phagocytosis, and intracellular bacterial killing. Cell-mediated immunity, as measured by skin testing, also is compromised and has been related to both decreased lymphocyte activation and suppressive mediators present in the serum of burn patients. A reduction in immunoglobulin synthesis also has been encountered in these seriously ill patients. Whey is one of the proteins found in milk, the other is casein. Whey protein accounts for only about 20% of the total protein found in milk, while casein makes up about 80% of milk protein. Whey protein is rich in certain amino acids and low in fat. The key amino acids, which are also branched-chain amino acids, are leucine, valine, and isoleucine. Whey's amino acid profile makes it ideal for body composition and to support protein synthesis and muscle growth. Another amino acid, cysteine, can be found in relatively high amounts in whey protein. Augmenting the availability of cysteine in diet has been found to boost immune function, enhance resistance to infection, and elevate glutathione, GSH, levels, an antioxidant enzyme containing cysteine. The availability of cysteine within the cell is the apparent rate-limiting factor in the synthesis of glutathione to replenish the cell's store during the immune response. GSH plays a central role in the functioning of immune cells, in particular its creation and maintenance of T-cell lymphocytes, the body's frontline defense against infection. By maintaining high intracellular GSH levels, oxidative damage can be minimized. This can also prevent disease and aid recovery. Whey protein also contains lactoferrin, a protein that has been shown to possess bacteriostatic and bactericidal activity. Studies on lactoferrin have demonstrated its ability to activate natural killer cells and neutrophils, induce colony-stimulating factor activity, and enhance macrophage cytotoxicity. Lactoferrin also has antiviral, antifungal, and antibacterial properties. The antimicrobial effect is likely more potent in organisms that require iron to replicate, as lactoferrin has the unique ability to chelate iron in a way that deprives microorganisms of this essential nutrient for growth. Lactalbumin, an important component of whey protein, has been found to raise brain serotonin, reduce cortisol concentration, and improve mood under stress. Casein has the unique ability of forming clots in the stomach. This makes it a very efficient in nutrient supply. The clot is able to provide a sustained slow release of amino acids into the bloodstream, sometimes lasting for several hours. This will generally aid in meeting the demand of the body for an increased supply of amino acids, providing energy, and promoting protein synthesis.